This is problem 29 in chapter 3, where an archer shoots an arrow 75 meters with an initial velocity of 35 meters per second. We are given that the initial velocity is 35 meters per second, but we are not given the angle, so we're asked to find what is this angle here. So let's take a look at what we know. First of all, there's a component of v0 in the x direction. That's v0 cosine theta. I don't know the value of that, but that's a perfectly good algebraic expression for it. I also know that in the y direction, v0y equals v0 sine theta. So what is it we know and don't know? Let's go to our table here. Stop the tape and take a minute to fill out this table as completely as you can. You should be able to fill out almost every cell. So what is it we know? Well, at time t equals 0, our position in the x and y is 0. In the acceleration, my y acceleration is 9.8 meters per second, and my acceleration in the x direction is 0. What about our final positions? Well, we're at 75 meters in the x direction, and I'm back at 0 in the y direction. Sorry, I messed this up here, didn't I? My acceleration in the x direction is 0. Now, my initial velocity in the x direction is v0x, which we had an expression for. Since the acceleration is 0, my final velocity is also v0x. This finishes at time tf. I don't know what the value is. I'm not asked for it. Maybe I need to find that. And then in the y direction I have v0y. And what's the vertical velocity just before the arrow hits the ground? Well, since it's at 0 altitude, then it's the same size as the vertical velocity at the beginning. So I know that it's also v0y. But the initial velocity points up, this one points down. Alright, let's go back to this situation and see what we can use. This is a useful application of the range equation, which is the range equals the velocity times the sine of twice the angle divided by g. Remember, g is 9.8. It's positive, and if you use it, you have to either point it up or down. This equation takes into account that g is acceleration in the downward direction. So that's our actual g is 9.8 positive here. So how do I solve this? Well, I want to find the angle theta, so I have to move g over, move v0 squared down, and then have to take the inverse sine of it and divide by 2. So when you put all that together, I get theta equals 1/2 sine negative 1 of g times r over v0 squared. Now g times r is the 9.8 meters per second squared times the range is 75 meters, and I'm going to divide that by the velocity squared. Okay. When you calculate this all out, you get 0.6, and it turns out to be unitless. If you look at this, on top we have meters squared over seconds squared. On the bottom we have meters squared per second squared. So all of the values cancel. This leaves us with 1/2 inverse sine of 0.6, and that equals 18.4 degrees.